Okay, so another function. We've got the limit as x goes to 0 of the quantity 1 plus x raised to the 1 over x power. Okay, so we're going to figure out where that happens when this goes to 0. You can't just directly substitute in 0 because then you would have 1 divided by 0 up here, which is not possible. All right, so you can graph it and then do the table. All right, when you're graphing, make sure you do parentheses around this and then raise it to this power, and I would put parentheses around those too, just because that's what I do in calculators, but it's up to you. All right, when you graph it, let's see, here's 1, 2, 3. You're gonna get a curve that kind of comes down like this, okay? So as we're approaching 0, it looks like it's crossing at the same spot on the left and right side. So from the right side and from the left side, you're approaching the same value. Okay, so it does have a limit. We just got to figure out what that is. All right, so what I would do is make a table. All right, so we're approaching 0. So for the table, we do 0, we do 0.001, 0.01, 0.1. We're going to do negative 0.001, negative 0.01, negative 0.1. You do not have to use the same values as me, by the way, but it works. But you just need to be approaching close to 0 on both sides, okay? So choose whatever decimals you want to do. You can keep going. You could be like 0.0001, however you want to do it, okay? You at least need 3 on both sides so you can actually see where it's going, okay? All right, so if you do that and then you do your whole second table set, ask for these values in your table, you'll get 2.868, 2.732, 2.719, it's undefined at 0, 2.716, 2.704, and 2.593. Okay? So we are approaching from the left and from the right. So we have 2.719, 2.716. So it looks like we're approaching some value of approximately 2.71 something, right? Okay? So it looks like it's agreeing, so I would say yes, it's got a limit. It's approaching this value. So it's approximately 2.71. Now, what it's actually approaching is a really famous math constant, okay? So it's approaching the number e, okay? So I don't know how much you have worked with that. I know you know pi, like 3.14159, blah, 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 okay? E is another one of those famous math constants. So this is actually approaching the value of e, which is 2.7182, dot, 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 dot. Keeps going, okay? So, just a little random fun limit right there. So that's what you do for that one. Okay, take a minute and pause if you need to, so that you can write that down. And we'll do part D. All right. Part D. Limit as t goes to 1, so they change the variable on you. T to the n minus 1 over t minus 1. For a general positive integer n. Okay? So t is like your x, okay, so that's your variable for your equation, all right? N is a number, which it wants us to choose a number, so for a general positive integer n, okay, so basically it's going to work for any general number. We're going to figure out what the pattern is, okay? But to do this, we need to like test some numbers, or at least to figure out what's happening. So what I want you all to do is choose a number n, okay? It has to be a positive integer, so 1 through infinity. Okay, choose a number for here and then you're going to plug in a number for that, okay? So for example, if you did 3, you would be doing t cubed minus 1 over t minus 1. That would be your equation, all right? So I want you to pause the video. This will be like a way to test yourself and see if you've got this, because if you can do this on your own, you're good to go. All right, so choose a number for n, and then I want you to graph it, and then I want you to make a table approaching 1 and see what you get, okay? So see what you get for your answer. So pause and do that, and then when you come back, you can watch what I do and see if you did the right process, and then we're probably gonna get the same conclusion, okay? So pause and do that. All right, so I'm assuming that you paused, you're coming back and checking now. Hopefully you are. All right, so I'm gonna choose n equals 2, okay? So mine's gonna look like this. The limit as t goes to 1, or t squared minus 1 over t minus 1. Okay, you can't directly substitute in, because if we just put 1 here, we get 1 minus 1 divided by 0. Can't do that. All right, so my graph looks like this. There's -1, there's 1, 2. Okay, so when we get to 1, I'm up here at 2, and it goes like this. Okay, so if we're approaching 1 for mine, from the left and the right, we're at 2, okay, which we're going to verify with the table, not just use the graph. So for my table, we have 1, 0.999, 0.99, 0.9, 1.001, 1.01, 1.1. Okay, so it's undefined at 1. Then I got these values when I plugged mine in. 0.99, 1.99, oops. 2.001, 2.01, 2.1. So it looks to me like it's approaching 2 from both sides. Okay, so the limit for mine is 2. Okay, now I'm betting if you chose a different number, you ended up getting what number you chose. So if you chose n was 3, your answer ended up being 3. Or if you chose 5, you ended up getting 5. Or if you chose 100, you got 100. So whatever number you chose. So the answer for this limit is that it ends up equaling whatever n is. All right? There you go. That's that limit. All right, so take a minute, write this down if you need to, or check yourself. Let me know if you have any questions on any of these and need help. All right, I'm going to stop this video and start another one so you have like more segments.